Welcome to Forge College. Okay, so if you've been following along in our overarching journey, that massive transition from the Ethereum virtual machine over to the Solana virtual machine, you know we've been really deep in the weeds lately. In our previous explainer, we focused heavily on documenting design decisions and comparative notes. We gathered all our ingredients, tasted the batter, made our notes, the whole shebang. But today's the big day where we put it all together. We are synthesizing all of your hard work into a final, published master blueprint for transitioning from Ethereum to Solana. We're going to assemble and publish the Solidity-to-Rust and Anchor pattern catalog. Think of this explainer as the table of contents for an engineering cookbook. We'll be hitting 6 key steps today: the master blueprint, structuring entries, the automated stress test, AI refactoring, peer review, and finally publishing.
All right, let's dive into Section 1, the master blueprint.
So, you know how you've spent all those earlier lessons gathering ingredients, writing out translation rules, and taking meticulous notes? Well, now it is time to officially step out of the kitchen and become a published author. We're taking the 10 draft translations you've been working on and synthesizing them into one final version-controlled, searchable knowledge artifact. This right here becomes your canonical pattern set. When a developer inevitably comes up and asks, wait, how do I translate this Ethereum concept into Solana? This master blueprint is exactly where they're going to look. It needs to be searchable, it needs to be version controlled, and it has to be impeccably organized.
Moving right along to Section 2, structuring your catalog entries.
Look, a cookbook is pretty much useless if one page is formatted as a poem and the next is written in hieroglyphics, right? Every single entry must have an identical, machine-readable anatomy. They essentially act as indexed specification pages, which means they require strict metadata. What's the title? What's the category from our taxonomy? Which Solidity compiler version was tested? What about the Rust toolchain? Is the status draft or ready? And is the compilation full or partial? By standardizing all of this, automated migration tools will know exactly how to read, index, and apply these patterns without any human intervention at all.
Now, the absolute heart of your catalog is a side-by-side visual mapping. Think about a classic Solidity ownable contract where we see familiar things like address public owner and msg.sender. When you compare that directly with the Rust and Anchor translation, which uses an ownable state struct and a set owner validation context, something really cool happens. It illustrates exactly how an EVM concept like msg.sender translates beautifully and safely into a Solana signer account. Seeing those concepts map directly to each other, that is what triggers the aha moment for transitioning developers.
But wait, you can't just drop raw, naked code onto a page and call it a day. Code without context is honestly a recipe for disaster. You absolutely must provide inline mapping comments that explain your design rationale. Why do we choose an idiomatic anchor rewrite over direct fidelity? What are the security trade-offs? Like, how does ownership validation actually differ in a stateless model? And finally, you have to provide explicit when-to-use migration notes. This tells the reader exactly under what specific circumstances this pattern is the right tool for the job.
Up next is Section 3, the automated stress test.
Okay, so you've written the recipes, you've formatted them beautifully, but do they actually bake? Now comes the fun part. We are running your recipes through automated stress tests to make absolutely sure they compile. We use a strict 3-step validation sequence for the rest snippets. We place your code inside a minimal anchor scaffold just to give it the context it needs, and then we run our checks. First, cargo check, to ensure the types and logic actually validate. Second, cargo FMT, just to make sure the code styling is clean and uniform. And third, cargo Clippy. Now, Clippy is Rust's incredibly opinionated linter that catches unidiomatic code or potential bugs. We run these tests to ensure everything works flawlessly before a human ever even looks at it.
Your ultimate goal here is that big, beautifully satisfying zero Clippy warnings. It basically means you've successfully navigated the compiler's strict rules, and you've managed to avoid it yelling at you in dark green ink in your terminal. If you hit 0, your code isn't just compiling, it's structurally sound and perfectly idiomatic. Which brings us to Section 4, AI refactoring and logs.
So how do you efficiently get to that perfectly formatted code? Well, we can actually lean into a little bit of AI vibe coding to clean up our anchor syntax. The workflow goes like this. Export your snippet to your AI tool. Prompt it specifically for anchor best practices. Ask it to generate a minimal test wrapper so the code can compile locally and then run your checks. But there's a hard, non-negotiable rule here. You must log all changes.
You can absolutely use AI to format non-idiomatic constructs, but you have to carefully and meticulously document those changes in your changelog. We have to maintain full transparency about what a human wrote versus what an AI refactored.
All right, Section 5, Surviving Peer Review.
Automated linters are great, right? They're like an excellent spell check. But once the machines say you're good to go, surviving the human editor's desk is your next major hurdle. You are going to hand off your checklist markdown file to a peer. And crucially, it has to be a peer who did not translate the entry themselves. They're going to look for template compliance. Is the metadata 100% complete? Are the compile and lint logs physically attached to prove the code works? And most importantly, does the annotation mapping actually make sense? Making sure the logic makes sense to fresh eyes is absolutely vital before anyone applies that highly coveted reviewed stamp. I mean, if your peer doesn't understand your translation today, a developer 6 months from now certainly won't either.
Finally, Section 6, Publishing your pattern catalog.
Once all 10 of your entries pass the automated linter gauntlet and that rigorous human review, it is finally time for the book launch. You will officially tag your Git repository with this exact release version, v1.0-pattern catalog. And this isn't just a label, it's a guarantee. It defines a release containing 10 fully validated, peer-reviewed entries with complete handoff metadata. Applying this tag gives a really satisfying official stamp of approval to your entire Capstone project. It declares to the world that your catalog is ready for production.
So I'm going to leave you with this question to chew on. Is your master blueprint ready to power a real-world migration? Because it's about to. Thank you so much for hanging out with us at Forge College for this explainer. Be sure to head over to forge.college to learn a ton more about this subject, dive into other fascinating Web3 topics, and get your hands on some amazing educational resources. Go get that catalog published and tagged, because in our very next explainer, we're going to use this newly published catalog as the foundation for planning your migration environment. I'll see you there.